Hello students, today we are going to discuss about the unit test 1 physics paper that we had given almost a month before. Now here is the time to look at the solutions, and I would be also giving you the review of the test paper which I had checked. So let us go step by step. So let us look at problem number 1. So this is an MCQ question. In gases, intermolecular spacing and intermolecular forces are respectively, the answer is D, large. The intermolecular spaces are large and the intermolecular forces are weak. Buoyancy refers to upthrust. Buoyancy and upthrust are one and the same thing, right? It does not mean total upward pressure, total downward pressure and apparent weight. All three options are wrong, right? Okay. The third MCQ states that dash is the direct change of state from solid to direct gas. The answer is sublimation. Which of the following is transmitted faster by solids? The answer is heat and sound both. So our answer is D. Torque is equal to force multiplied by distance. So Newton multiplied by meter. So answer would be A option. Sorry, the answer would be C option. This is a typical problem related to pressure in liquids. So pressure is equal to H rho G. Now since these 3 points are in the same liquid, rho is same for all, G is same for all, but H is the depth, C is at the least depth, A is at the highest depth. So the pressure at A would be the most, B option. Let us move on to true and false type of questions. To decrease the pressure, the area has to be decreased. This is false. It is because pressure is equal to force upon area. Pressure and area are inversely proportional. So if you want to decrease the pressure, you have to increase the area. Then and only then the pressure would be decreased. Density of water at 4 degree is 1000 gram per centimeter cube. It is again false. It is 1000 kg per meter cube in SI unit, or you can also write it down as 1 gram per centimeter cube. Latent heat of fusion results only in melting. That is again false. When you give latent heat, the solid changes into liquid, but when you remove the latent heat, the liquid again changes back or freezes back into solid. So it can be also written as latent heat of fusion results also in freezing. So in melting and freezing both. Now I would be discussing the short answer questions at the end. Now here let us look at the numericals, because most of the students have made some or the other calculation errors over here. So the first question is calculate the heat required to convert 0.5 kg of ice, and the latent heat is given. And see, first of all, how to solve a numerical. This is question number D and the first one. So first of all, I'll write down what is given to me. So what is given? I am given the mass as 0.5 kilogram. Then I am given the latent heat of fusion for ice, that is 336 joule per gram. Now I'll apply the formula Q is equal to ml. Instead of mass, I am going to substitute 0.5 kilogram, and this is 336 joule per gram. But if I directly multiply, my answer would be wrong, because this is given in grams, this is given in kilogram. So what I am supposed to do is either I will convert this into kilograms or I will convert this into grams. So what I am going to do is Q is equal to, I am going to convert this into gram, because anyhow gram and gram are going to get cancelled. You can also choose to convert this into kilogram, that does not matter. So 0.5 kilogram, 1 kg is equal to 1000 grams. So multiply by 1000. 336 joule per gram. Now this 0.5 into 1000, this is gram, so gram and gram getting cancelled. This can be also written as half into 1000 into 336 joule, so getting cancelled. So Q is equal to, this would be 168, so 168 and 3 zeros at the back, joule. This is the answer. So look at the way how I have done this one. I have applied the proper formula, I have written the given things, then I have also made sure that the units are properly written over here, and finally I will be underlying my answer. This step is not necessary, but if you do it like this, the presentation of the numerical would be more better. Look at the second numerical. The empty bottle weighs this, then filled with water weighs this, filled with liquid weighs this, and relative density is to be found out of the liquid. So again, number 2, see, if you write down is equal to in just below is equal to and then solve the numerical, it would be more appropriate. So relative density for the liquid this is the formula. Now I will also write down what is given to me. First of all, you must know what is M1, M2, M3. So M1 is the mass of the empty bottle, and that is given to us as 20 grams. So M1 is 20 gram. M2 is the mass of empty bottle and water completely filled in it. So that is given to us as 55 grams. M3 is the mass of empty bottle and the liquid which is completely filled inside it, that is 40 gram. Now I am going to put the values over here. So 40 gram minus 20 gram upon, this is 55 gram minus 20 gram. So again is equal to, below is equal to, this is now 20 gram. Now this is 35 gram. Gram getting cancelled. Now you can choose to cut this by 5 4s are 20 and 5 7s are 35. So this is 4 by 7. Now 4 by 7 is approximately equal to 0.5, but still let us check that. 4 divided by 7, 0.57. So here this answer is 0.57. This is our final answer, and relative density does not have any unit. Correct? Okay, so let's move on to the next problem. The third problem is related to torque. Now in third problem, you are given the value of force as 65 Newton. So, sorry, I'm talking about the fourth problem. I have skipped out third problem. So the third problem, what is given to us as, you are given the area as 2.5 meters square, and you are also given the pressure as 650 pascals. Now we know that you can also choose to draw this triangle and remember the formula that pressure is equal to force upon area. So force is equal to pressure into area. So I am supposed to find out what is force. So force is equal to pressure into area. So pressure is given to us as 650. Pascal is Newton per meter square. Area is 2.5 meter square. Now meter square getting cancelled. 650 into 2.5 can be also written as 5 by 2. Now if I, and final answer would be in Newton. So 650, 2 ones are 2 threes are 6, 2 twos are 4, 1 5. Now 325 multiply by 5 would be equal to 1625. So my answer is 1625 Newton. Correct? So this is how it is to be done. Now the fourth problem is related to the torque. So problem number 4. Force is given. Then we are also given the distance, and distance is 15 centimeter. Now the formula for torque is equal to force multiplied by perpendicular distance, that is d, that is what is already given over here. So we need not to apply torque is equal to Rf sin theta, because it is not mentioned anywhere. So if it is not mentioned, this distance is the perpendicular distance. No need to take sin theta value. Now torque is equal to force, that is 65 Newton. Distance, it is given in centimeter, and this is in SI unit, this is in CGS unit. So what I'm going to do is I'm going to divide this by 100. So this would be 0.15 meter, and this value I'm going to substitute it over here. Most of the children have made mistake over here. They have directly multiplied without seeing it is an SI or CGS unit. So torque is equal to 65 into 0.15. So 65 multiplied by 0.15 is 9.75. Then Newton into meter. If you don't write down the unit, marks are definitely going to get cancelled. So this is how, with neat and clear way, you are supposed to solve the numerical. Yes, since I was having the calculator, I was doing the calculations over here, but if you are writing the, if you are doing the rough work, then make sure that you draw a line somewhere over here, write rough work, and then you do all the calculations over here. Make sure that you don't do the calculations in between, or here or here or here. Make a proper space and then do the rough work over here, and never mix your rough work with your original problem solving area. Correct? Now here I'm also showing you an image. If you look at this image, you will see that the student has not mentioned any formula. He or she has also not written the given points. The final answer, units were not mentioned, or if mentioned, it is incorrect. And the bifurcation of the rough work and the space is rough work, space, and our original answer sheet is not shown. That's okay for me, but student has not at all written what are given things, what is to be found out, no mentioning of formula, no units. So this is a very bad piece of work. On the other hand, this image shows that very clearly all the points were mentioned, formula was properly applied, units were mentioned, and they highlighted, and he or she has also highlighted the proper answers. Here is an image in which the formula is not properly mentioned. You can see that torque is equal to force into distance, but instead of distance, the student has written meter. That is not appropriate. Newton is written in small letter. Newton is a unit, always to be written in capital at the side. And look at the way which the student has calculated the numerical very hastily. The student has calculated the numerical without checking that both the both the things which are given are not in SI or in CGS unit. Just simple multiplication was done and got the incorrect answer. Here is another good work done by a student. Neat and clean work, all things properly mentioned, formula properly mentioned, but look at the last error in the formula. Instead of M3 minus M1, the student has written M2 minus M1 on the top, and 7 by 4 was not the answer, it was 4 by 7, and very hastily the student has made a mistake. In some of the occasions, the student have also written 4 by 7 as 1.75, whereas 4 by 7 is 0.57. So do take care in all these kind of calculations, right? And so we move on to the next problem. Now, look at this particular question. In this question, the balloon is inside the water. Now this balloon is at a very low depth. If you look at this depth, then this balloon is at a larger depth. Then the pressure exerted by the liquid on the balloon, or the pressure exerted by the liquid, is equal to h rho g. And since this balloon is at a lower depth and this balloon is at a higher depth, so the pressure exerted by the liquid from all sides would be very large. So due to that, the size of the balloon is less. So you should have written like this, that the pressure exerted by liquids increases with depth, and you can also mention this formula for better clarity of the answer. Okay, now over here, question number 2 states that there are 3 cubes. For cube A, density is given, mass is given, and volume is to be found out. So let us calculate that. So this is question number 2, and for A, volume, again, if you are a bit confused, you can check out this formula. You can make this triangle. Density is equal to mass upon volume. So volume is equal to mass upon density. Now, what is mass given to us? 6.75 grams, and the density was 0.25 gram per centimeter cube. So what is going to happen over here is 6.75 divided by 0.25, and this centimeter cube will go up, gram getting cancelled. Now this is 6.75. 0.25 can be also written as 1 by 4. Final answer would be in centimeter cube. So this 4 would be going up. So 6.75 multiplied by 4 centimeter cube. So the answer is 27 centimeter cube. Also, just look at the way how I have done the numerical over here. Now for B part, they are giving us the density and volume. So we are supposed to find out the mass. So from again this triangle, mass can be written as density into volume. Density is given as 19.3. Volume is given as 8 centimeter cube. So if I multiply, these two get cancelled, and 19.3 multiplied by 8 is 154.4 gram. This is our answer. Now for C, mass and volume are given. Density is supposed to be found out. So density would be equal to 10 by 4, that is 2.5 gram per centimeter cube. This is our answer. Now, since we know the density of all three, let us substitute the values over here. This was 27 centimeter cube. This is 154.4 and this is 2.5. Correct. Now we are also given in another situation in which this is water, this is mercury, and these three cubes, we know the density of all these three cubes. Now the sinking and flotation concepts can be only discussed on the basis of densities. Cube A has very less density, even less than the water. So A cube even cannot immerse inside water. So if you write down A over here, it would be wrong. A would be somewhere over here. So you can expect the cube to be somewhat like this. If you have just written the letters, then also it is fine. Now cube B has got highest density, even more than that of the mercury. So this is going to sink down and the cube C would be somewhere over here. Cube B would be over here. And C is having more density than water, so it is definitely going to sink inside water, but it cannot go inside mercury. So somewhere over here would be cube C. It has sunk inside the water, but it cannot go inside the mercury. So the correct pattern is ACB, right? Okay. Now let us talk about the last question. This we had already discussed in the class. Here we can see that a solid, the temperature of the solid is increasing. So this cannot be melting because we are asked which part shows the melting. So this is solid and solid temperature is increasing till point B. Then the temperature remains constant. So when the temperature remains constant and time passes, we are supplying the heat energy. So the heat energy results in change of state. So this part is melting. So B part is the correct answer, because when state changes, so this is boiling, because when state changes, the temperature does not change. So over here we can say that when solid changes into liquid, the temperature does not change. So B part is the liquid. And almost we are at the end of our video. Now I would be also giving you the correct answers of all these problems over here.